of called cost, because this is what we want to find the minimum for. So the cost function consists of two pieces: the metal part of the fence plus the wood part of the fence. I also know something very important, that this base is basically what? Is the enclosed area, and I have it. It's given to us. So can anyone give us an equation that involves this, all these pieces that I'm showing here?
X times Y equals 5,000.
Excellent. This is carved in stone. The length times the width is given to us as being 5,000. Perfect. So now let's talk about the metal piece. They are not telling us how high this is. Are they telling us? Is to be included at 3 sides, including the is a chain link fencing. Okay, so we are not. So it's just a wire. Okay. So the only concern I have is how high this is. But here it's just a wire, okay? But I'm not so certain about how the wooden fence will go, because it doesn't say anything about height. Dimensions of this all cost to enclose the area, and what is the minimum cost? Okay. So the area, so that's right, it's base times height. So since this is just a wire, I will have the length x twice, of course, because it's rectangular. So this is x and this is also x, multiplied by, so x plus x, 2x, multiplied by the cost per foot. That's all we have, because it's not per square foot, so it's just the length. So 4.5. And plus, again, here I have y times 4.5. And here we have y times 7 plus y times 7. And this is the cost function. But I wrote here cost of x, but I have a y inside. This has to go. I can't have a function. So here, to be exact, it's a function of two variables now. But we don't know yet how to differentiate a function of two variables. We will. Towards the end of this course, we will differentiate functions of more than one variable. But right now, we are restricted. But this is very easy. It comes out to determine, it comes out of this. So y is definitely 5,000 divided by x. So there is no problem to replace it here. So now it is true that the function called cost is just a function of x. So 2 times 4.5 is 9x. This is 7 plus 4.5, which is 11.5. I factored it out because now I multiply by 5,000 divided by x. So this is our cost function. I can multiply these two as well. Where's my calculator to do it fast?
You have to add a second 5,000 divided by x since there's two y's.
I factored out. I factored out y. So I replaced, very good point. I'd rather go back always and check. I wrote that this is 11.5 times y.
Okay.
So instead of these two terms, I only wrote one term.
Okay.
So 11.5, and I replaced that. So this will change into 9x plus 57500 over x.
Thank you.
Thank you. So now this function will be differentiated. We talked about this, but let me just say one more time. that whenever we differentiate 1 over x, I would like us to remember that this is negative 1 over x squared. It will be very useful when we go backwards. In a later chapter, we're going to be given this, and we would want to find that. Right? We know how we get this. This is x to negative 1 prime, which is negative 1 times x to negative 2, which is this. It will save us a lot of time if we would remember this moving forward. I differentiate 9x, I get 9. And then this is 57500 over x squared. Yes, before I set it equal to 0. X equals 0 is not a critical number. How come? Well, because if x is 0, then I don't have the 5,000 square feet. So x cannot be 0, y cannot be 0. Okay, so then before I set it equal to 0, I have to find the least common denominator. And I have to multiply it by this. So 9x squared minus 57500. This reminds me of one comment to make. I've seen it in some of the work, something like 7 over x minus 3 over y as being 7 minus 3 over x plus y. I've seen it last week or 2 weeks ago. You can never do this. You have to find the least common denominator. You can just simply say 7 minus y over x plus y, 7 minus 3 over x plus y. Please, regardless of how tempting this is, please do not do it. We know we cannot add or subtract fractions unless we find the least common denominator and we make the necessary adjustments, right? Because this is over 1. So please pay attention to that. Okay, so now I can set it equal to 0. A fraction is 0 only when the top is 0. We know that. When the denominator is 0, it's a tragedy. So then 57500, is this divisible by 9? I doubt. So I get that x squared, and then I take the square root from the previous answer. So I got that x is approximately 80. So 80 feet. And that will give us the y value. However, let me just double check my divisions here. So I divided 57500 by 9, and then I took the square root. So 57. I'm just checking just to make sure that I don't have any errors here. And the square root of the previous answer. Yeah. Okay, so now we can say this gives us a minimum cost. You cannot conclude that before you show that that is the case with c prime of x. So 0, it cannot be, I cannot put infinity in here, so x cannot be more than, I don't know, 1,000. You can even put 5,000, which is the entire area, which is not possible, right? But anyway, so 80 is somewhere here, and I have 0. And I have to study the sign and see the signs here, not just put some symbols. So do not plug in x squared. X squared is always positive. That's why I'm not going to worry about it. So when I plug in 0 here, it's negative. And when I plug into the right-hand side, right, because these should be plus or minus negative, so in between solutions is always the opposite sign. It's quadratic. So this has to be positive. So now I know that this is indeed the minimum. So x equals 80 feet will give the minimum cost. Any questions on this? Any questions?
So 80 feet, that's the minimum cost?
No. This is, where's my previous page? No. This is 80.
Okay.
And this will give a minimum cost. We'll determine the minimum cost in a minute, but I just wanted to make sure before I go to the next page. Is this clear?
Yes.
Now I have to find the y value, and then I will find the minimum cost.
Okay, and you just divide.
Because we are
5,000
asked
by-
to find both. We're asked to find the dimensions. Yes, I will divide 5,000 by x to get the y. Yes.
Thank you.
Thank you. So this is my page 4. So in order to find y, we have 5,000 divided by roughly 80. It was 79 points, blah, blah, blah. I rounded up to 80. Okay, so let's see what y is. So 5,000, just 500 I should have divided, but anyway. So 62, so y equals 62.5 feet. So the parking lot should be 80 by 62.5. The area has to be 5,000. It's going to be probably a little bit more because I increased this. I rounded it up. So this is 5,000 square feet. And now the minimum cost, C of 80, should be, let me go back to, where is it? So here is the cost function right here. So 9 times 80 minus, no, it's plus 57500 divided by 80. So 720 plus 57500 divided by 80, which we had before. I didn't have to do that, but anyway, the cost is 1438.75 for the fence. You can round it up to 1,439. Very good pick. Is this okay? So we found the dimensions of the rectangular parking lot that we would like to fence the way they told us. It's I would have given a little bit more information in this problem than they just said, but that's fine. Okay, this was a minimum cost. Let's see what else is here. We already looked at the minimizing the cost. Again, minimizing cost. Okay, let's go back.
Can we do something from the first page, the 255?
Yes. I'm going back to 250. Oh, this one?
Yeah.
Good, I'm ready.
20?
20. Okay. Continuous designing. So this is basically this. Okay, it's a rectangular box this time. That's fine. Let's do it. Okay, 20 on 255. I'm going to come up with a figure and then I'll stop sharing. So is designing an open top square based. Okay. So the base is a square and we do not have a top. Okay. Which means that it's x at the bottom. They will have a volume, so the volume is 62.5 cubic inches. Perfect. What dimensions will minimize the surface area? So we want to minimize surface area. Perfect. What is the minimum surface area? Good pick. Thank you. So we want to build a box. It does not have a top, and we know that the base is a square. So that's why I put x, but it has to have a height, which is not given to us. But we know from here that the volume of this box has to be 62.5. Oh, look at that. Nice. 62.5 again. So now, anyone remembers the volume of a box? Area of the base times the height. So if it's a rectangular box, area of the base, which in this case is a square, multiplied by the height. And that in our case is 62.5 cubic inches. And what is the area of a square? Can anyone give us this area?
Is it 4 times x?
But are we adding or we are multiplying?
Multiplying?
Okay, so if we multiply length, width times length, then what do we get?
X squared?
Thank you. X squared times the height equals 62.5. Good. And from here, I'm assuming we're going to have to eliminate one of the variables, and I really don't want to eliminate x. I would like to eliminate the height. So I already have it ready. It's 62.5 divided by x squared. Now remember what we said. We have to create the function. If we don't find the function, I cannot find the minimum. So now let's think in terms of the surface area. And we notice that the sides are all equal in surface, right? In area. Base times height plus base times height plus base times height plus base times height. Just the base is different. So now let's create a surface area function of x only. We have the base, which is x squared, plus 4 base times height. Instead of the height, I'm going to put this. Any questions so far? Any questions so far? Do we understand how we create the surface area? Yes? Everyone?